Welcome to qnawire.
For this problem on the topic of center of mass and linear momentum, we are shown in the figure a particle with a given mass sliding rightwards along the x-axis on a frictionless floor with a given speed. It reaches the point x is equal to 0, at which it undergoes a one-dimensional elastic collision with another stationary particle. We are also given the mass of that particle. The particle then reaches the wall at the distance xw. It then bounces from the wall with no loss of speed and strikes particle 1. We want to know the position on the x-axis that particle 2 will then collide with particle 1. Now we know we can find the velocities of the particles after the first collision, which is at x is equal to 0 and t is equal to 0. Using the equations, we know v1 f, the final velocity of particle 1, is m1 minus m2 over m1 plus m2 times the initial velocity of particle 1. And these values are known, so this is 0.3 kg minus 0.4 kg over 0.3 kg plus 0.4 kg multiplied by the initial velocity of particle 1, which is 2 meters per second. And so calculating, we get the final velocity of particle 1 to be minus 0.29 meters per second. The final velocity of particle 2, v2f, is equal to 2m1 over m1 plus m2 times the initial velocity of particle 1, v1I. And this is 2 times 0.3 kg over 0.3 kg plus 0.4 kg. And this again is multiplied by 2 meters per second. And so calculating, we get this to be 1.7 meters per second. So now we know the second particle's velocity after the collision, as well as the first particle's velocity after the collision. And this is after the first collision. So at a rate of motion of 1.7 meters per second, and we know that 2xw, for the second particle to reach its initial position, that's 140 centimeters. That's the distance of the wall and back to x is equal to 0. This will be traversed by the particle in 0.82 seconds. Since we know v2f is 1.7 meters per second, we get t to be 0.82 seconds. At this time, we can find the position at which particle 1 is located. And so particle 1 is at position x, which is minus 2 over 7 times 0.82. So it's position minus 23 centimeters. So it's moved off to the left when particle 2 has now returned to the origin. So particle 2 is now gaining at a rate of 10 over 7 meters per second leftward, and this is their relative velocity at the time. So the gap of 23 centimeters between them will be closed after an additional time, which we can calculate as follows. The additional time will be 0.23 meters multiplied by 10⁻⁷ meters per second. And this is equal to 0.16 seconds. So now at this time, 0.82 plus 0.16, the two particles are at the same position. So t is equal to 0.82 seconds plus 0.16 seconds. And this is 0.98 seconds. So at time 0.98 seconds means that the two particles are now in the same position, and this position is x, which is minus 2/7 times 0.98, which is the equation for particle 2, and this gives us the position x is equal to minus 28 centimeters. So that's the position along the x-axis where particle 2 will now collide again with particle 1.